Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a meetup group that we stream online on YouTube, and we also have in-person meetups to help people getting into Python get through those initial steps, and also people who've been using Python for a while to learn about machine learning and how Python can be used in that area. Tonight I'll be looking at how to do automatic testing of Python programs. And so yes, that's what we'll be doing. If you want to chat during the stream, you can talk to us on Slack. There are details below this YouTube on how to communicate on Slack, and Leo sent this message. You've got a bit of competition tonight with the Artemis launch. Now, I didn't know about the Artemis launch. I'm imagining Artemis is the message queue software that can be used. And talking about message queues, in 2 weeks' time, on November the 30th, we'll be using message queues to do communication using Python programs between your PC and a Raspberry Pi computer. And that session, I'll do a quick half-hour session online, so anyone at home can work through it. But the main feature will be an in-person meetup in Brisbane City on the mall at our new venue, and so encourage as many people to come along to that as possible. And I'll have a Raspberry Pi there, and we'll see if we can write little programs that turn the LEDs on and off from remote computers. Alright, I'll also be listening to the YouTube chat. You can see here, I'll put that on live chat because Top Chat seems to censor a few of the messages. But yeah, so you can send messages there if you want as well. And quickly across. Alright, now to start with, we're going to use Google Colab, and I've put a link to a Google Colab. It's below the YouTube video there. You'll see the link there that says colab.research.google.com and then abbreviated, but you can click on that. I've also got it here on our meetup page. So if you click on that link, it'll open up in a new tab. And this is the Google Colab notebook that we'll be using to get started with. But I suggest the first thing you do is click on copy to drive, and that way you can see, you can type your own stuff in and save a copy to your own Google Drive, and that way you'll be able to keep a copy for all time. I'm also I'll share this one just in case I type something into this one that you want to keep. You can just use this link to use the link to see what I've typed in rather than trying to follow it on the screen if I'm too quick for you. So we want anyone with the link can view it. Alright, copy the link, done. Okay, so I'm pasting the link here into YouTube chat, and I also did it on the Slack chat, but you might find that it gets censored, but anyway, that was it. Alright, let's have a look at testing. So why would we want to test? When you write code, you often test it yourself, make sure it's all working, but sometimes things can happen in the future that can affect how your code that was working okay now works. Things like updated libraries, updated Python version, changes in your application, other modules, other functions, change variable data types. Those sorts of things can happen in a program. If you've set up automated tests, then it's really quick to just run the automated tests and check that all your functions are still running. But there's still a bit of a skill in writing the tests so that they're effective. Alright, so for tonight we're going to start off using Google Accounts, so you don't need Python on your computer for that. But if you do have Python installed, then at the last couple of exercises you can use that, and I'm going to be using the PyCharm Community Edition. You don't need that, you could just use a text editor, but it's certainly easier if you've got a proper IDE. Okay, challenge 1. I'll make this a bit bigger. Write a function called isLeapYear, year which returns true if a year is divisible by 4, otherwise false. Okay. So this is just an introduction to Python. How do we write a function? We use def to define a function. We give it a name, and we want the name to be isLeapYear, and it's going to take one parameter called year. Alright, so this is very basic stuff. At the end of, once you've defined the name and the parameters in parentheses, then you put a colon, and the colon says I'm about to start a code block, and in Python a code block is indented code, so indented by 4 spaces, and the code block will continue until you stop the indentation. Alright, Google Colab's worked out already that I'm going to indent, so it did that for me automatically. So we've got the year. We want to see if it's divisible by 4. So an easy way of doing that is use the modulus operator, and you take the year, you divide by 4 and find the remainder, and if that remainder is 0, then it is divisible by 4. So in this case we can return true. Otherwise, in all other cases, so that's the remainders 1, 2 or 3, will return false. Okay, and we'll run it to see if it works. So let's say is leap year, and we'll check the year 2020. We're running interactive Python here in Google Colab, so the last line that in your code cell, if it's got a return result, that will be displayed on the in the output. So I'll run this cell. It's going to take a bit of the time. The first time we run a cell in our notebook, because it's got to connect up to a computer. Google Colab's creating a compute engine backend for us using Python 3. Now it's initializing it. Now we're connected, and now it can run this. So I ran this by clicking on the play symbol or pressing Shift Enter, and it said the year 2020 that returned true because it was a leap year. Alright, so that's challenge 1. Now I've provided a solution here. Is leap year 1, so the 1 there is just really to say solution 1. So it did the conditional check year modulus 4 and equals 0, and really that'll return either true or false itself. So we'll just return the value of that, and that'll do the same as what we've done up here. So I'll run that. See, it's a lot quicker now. We've defined this other function is leap year 1, and we can check it works. So I've got a couple of print statements here. Is leap year 1 2022 is false, is leap year 1 2020 is true. Alright, our challenge 2 is check if that works programmatically. Now I'm not going to do that, it's pretty simple. We've got a solution here, we've got a few solutions, so we'll just go through the solutions, and you can decide which one you like the best. Alright, so let's run this solution. So what it's doing, if it says it is a leap year, then we'll print, yep, the function worked. Otherwise we'll print it didn't work. Okay, and that worked. Yeah, it says the function worked, and we know that it did work for the year 2020, so we're all happy with that. Now, that's sort of programmatically checking our function, but it now means someone's got to read through all the output, and if we've got a whole bunch of functions that we've just tested, we'd have to see, yep, function worked, function didn't work, and then find out which one didn't work and why it didn't work. So an alternative to that, to make it a bit easier to find which one did or didn't work, is we can raise an exception. And so if the code gets all the way to the end without throwing an exception, then we know all the functions that got tested worked for all the values that they were tested for. Otherwise, if it jumps out with an exception, we can find out what didn't work and see why it didn't work. And we can also put a bit more data than just 1 year, because it could be that it works in 1 year and doesn't work in another. So for example, we can create a list here of input data, output data, input data, output data, input data, output data. So each of these pairs, tuples of input and output data will go into year and a Boolean variable, which we'll just call tfleap, and we'll compare tfleap to what is leap year returns, and if they're equal, then everything is fine. We can just print something saying, yep, that was fine. If it's not equal, then we've got an error. So we'll raise, any sort of error, we'll do an assertion error as one that we can raise with a bit of a message saying what went wrong. So let's run this. Function correctly returned false for 2022, true for 2020, and true for 2000. That's right. So let's just put some bad data in here to see what will look like if it failed. So say 2001 was supposed to be a leap year. Let's see what it would do in that situation. So I'll run it again, and it'll throw an error. It's pretty clear now that one of our functions didn't work. We've got an assertion error. Is leap year 1 didn't work for the year 2001. It should be true, but it's actually false. Okay, now that's not actually correct, but I don't like having errors being thrown in my Google Notebooks, because if you're trying to run all the cells at once, it'll just get to one and then stop at that cell where an exception was thrown. Alright, so we're back and saying they're all correct. Now we've done a bit of work here raising an assertion error, but Python's actually got a keyword that does exactly that. So assert, we say some condition that's always got to be true. So tfleap equals is leap year 1 of year, and then we can even put a message if it fails, otherwise we can print. So it's just a bit of a shorthand to what we wrote up here, and probably a bit easier to read as well. Once again, it works, and if we said, let's have a look at what it looks like when it doesn't work, and does exactly the same thing. Right, so hopefully you've managed to run this notebook at home, and you're getting the same results that I'm getting. But let me know, this is supposed to be for beginners, so if you're having any trouble getting this to run, then just ask a question in one of the chat channels, and I'll see if I can help you. Okay, challenge 3, assert that 1900 is not a leap year. So in the calculation for leap years, the year 1900 is not a leap year. So let's see if our function worked for the year 1900. So to assert, we say is leap year 1 of 1900, and that should equal false. Oh, we've got an error in our function. So is leap year 1 is supposed to return false, but it returned true. So that's the solution for challenge 3. If we look at the solution 3 here, I'll fix the function so it returns the correct result. I'll fix the function down here, so let's just look at the solution. So let's look at the way we called assert to start with. This time I said is leap year 1 1900 equals false, but assert has always got to return a true. So another way of writing does it equal false is using the not keyword. So I could say assert that it's not a leap year in 1900, and that will give the same result. And now, so I'll run it just to check. Yep, assert not is leap year 1900. There's a problem there, and it tells exactly where the problem is. So I'll just comment that out so that we can get on to the next bit. So let's rewrite the function. And what the rules are for leap years is that every 100 years is not a leap year. So that's why 1900 is not a leap year, 1800 is not a leap year, 1700 is not a leap year. So all we do, we check first, is it a multiple of 100, in which case we'll return false. Otherwise, we'll just check that it's divisible by 4. And we'll call this new function is leap year 3, and we'll assert that not is leap year 3, 1900. And that all passed with flying colours because we didn't have any assertion errors. We didn't do any print statement saying it's success, but the fact that we got no errors means that it worked. All right, challenge 4, assert that 2000 is a leap year. So let's see if we've written this correctly. This is so similar to the last one, I think we'll just use the solution. Assert is leap year 3, 2000. No, it failed. Because we forgot about the next rule in leap years, which is that every 400 years is a leap year. Okay, so let's write another function, is leap year 4. The first thing we'll do is it divisible by 400 years. It is, then it must be a leap year. And then for every other year we check is it divisible by 100. If it is, then we're not a leap year. And then we check is it divisible by 4, and if it is, then it is a leap year. And we'll check that that works for the year 2000. And it does. So we can now, our function's getting better all the time, and we can have our little tests in there asserting is leap year 4 is 2000 is true, and that passed. All right, now these assert statements, you wouldn't normally put them in your production code because all they do is they stop your code, but they're very good to be used in testing code. All right, so another thing that you could do, challenge 5 says only run the asserts if the module is run as a script. So if you've got your functions in a module, so a module is a file, a Python file that ends in .py, and so you can put functions into a file, and you can either call functions from that file or you can run that file as a script. So if the module is run as a script, and not imported into another one, then there's a special variable in Python called underscore underscore name underscore underscore, and that will have the value underscore underscore main underscore underscore. There are two underscores both before and after, a bit hard to see because of the they're joined together, but there's two underscores there, and you'll often hear people refer to these special variables that start with 2 underscores as dunder, so double underscore. So dunder name, if I print the value of dunder name, it tells me that the answer is dunder main. So when I'm running IPython, it's as though I'm running this as a script, and I can check, and that's, so it's returning main. I'm not importing this file. So if I was to use this in my own script, I would have a function, check is leap year, and I only want to run this if to test this file, but this file is used normally as a module that's imported into other parts of my Python program, and so then it wouldn't run this check code, and therefore if any of the asserts fail, my code will keep running, but it won't and it won't just drop out, which is probably a better solution for production. You'd like your code to keep going rather than just show people an error message, even if sometimes it does give the wrong answer. Okay, so I ran this script, it checked the value of name, it equals main, and so it ran check is leap year, did all the tests, and then printed all tests pass. So you'll see this sort of code at the bottom of a lot of modules if you're looking at other people's code. So that's really what they're doing, is they're just checking to see if it's running as a script or if it's running as an imported module. Alright, so let's go off and set up a Python project. So this one you actually will need to have Python installed on your computer, or you can just follow along. So we're going to set up a project with the following structure. We're going to have a project name, so that'll just be the folder name. It's not a package, we don't have an init.py in here. We're just going to have a main.py, test.py, and our requirements. So, and I'm going to use PyCharm to make my project, but you could just do it with a text editor if you wanted. So I'll copy the code that's going to go into main.py, and let's go across to PyCharm. So I'll fire up PyCharm. I haven't got any projects open at the moment. So let's say we want a new project, and we'll call it Beginners Python and Machine Learning Session 165, and we'll create a new environment using virtual env. So check in there, if you are running Anaconda, then choose Conda, but if you're running Python, choose virtual env, and we'll store it in the same folder with just a venv, we'll call it. I've got Python 3.10 installed, so this virtual environment will be based on Python 3.10. Okay, so let's create this, and it's going to create a main.py for us. So you can see here's our project, BPAML 165. There's our main.py. Let's replace that with our special code. You can see it's just defining the function as we did before. We know how to fix it late, but we'll do that later, so I've commented it out for now, and we'll start off with our naive definition of what we think a leap year is. We'll save that, and we want to create two new files, test.py and requirements.txt. So here I can say right click on the project name, or it's really just the top folder, and say I want a new Python file called tests, and because it knows it's a Python file, it put the .py at the end, and I'll say new, and I'll just say a normal file. So this time I have to actually say that it's requirements.txt, give it the full name. Alright, requirements, so let's have a look. In requirements.txt, I'm just going to put one requirement, which is pytest. And in test.py, I'm going to put all of this code here. Alright, so if looking in test.py, I can see that when I try to import pytest, I'm getting an error. No module named pytest. And I'm not actually even using it at this stage in here, but anyway, I want to have pytest. But I've put it in requirements.txt, and PyCharm very cleverly knows that requirements.txt is going to be all the third-party modules that I want to install, and so it's asked, do I want to install that requirement? So if I just say yes, okay, Leo said we should put pytest HTML too in our requirements.txt. I'm not sure what that does, but we could put it in. And immediately it says, do you want to install that requirement? And we'll say yes. So I can see at any time everything that's been installed. If I go to File Settings, and on other computers I think that's called Preferences, I go down to my project here, look at Python Interpreter, and it shows me everything that's been installed. So it would start off normally with just pip and I don't know, setup tools, but all of these others are dependencies on pytest or pytest HTML. So by installing these ones, we've got all these extra packages have been installed for us. You can also see that some of them need to be updated. So pip, we can update that now. These little triangles tell us that it needs to be updated, so setup tools should also be updated. And also wheel should be updated if we want to have the latest versions. So let's get all them. Yep, so they're all updated. So those three were ones that came with our original virtual environment. That's why the latest copies weren't installed for us. And now if I go back to tests, I can see import pytest has no longer an error. All right. Now if you were doing that just from the command line in Windows Python, you could create your virtual environment called VNV BPAML 165. Then you activate the virtual environment by running that on the command line, and then once you've got the virtual environment activated, you'll see that the name of the virtual environment will be in parentheses at the beginning. In our case it's just venv, and then you can do your pip install -r requirements.txt. If you're on Linux or Mac, it's slightly different, and they've got Python. Then you activate it using the source command, and then once again you can run pip install -r requirements.txt. And if you've got Anaconda, then you use these commands to create the virtual environment, activate the virtual environment, and install the requirements. Okay, now from the command line we can run our tests. Okay, so I'm on the command line in terminal here, and I can type pytest, and no tests ran. Okay, so what pytest is supposed to do is look through all our files and find any that start with the word test underscore and a name. So let's go back to, oh yeah, we're here. Alright, so obviously my name of my file is not a good one with just test.py. So what I'm going to do is rename it to test_main.py. Refactor, rename. And now if I run pytest, it's run the tests, and it's found a failure, assert not true, where true is leap year 1900. So it's saying that 1900 should not be a leap year, but our current function says that it is. Alright, I'll just find the spot where I've written what the test file name should be. Okay, so this is where my problem is, but down here I actually said it should be called test main, and the name of your test file should be test underscore and then some name, or it can be some name underscore test.py. So the asterisk just means any other name. Alright, and we got, these are the results that we got. We had one test, it failed, and it took 100th of a second to run that. On my computer it took 1/10 of a second, so this computer's a bit slower. Alright, fix main.py by uncommenting code and run pytest again. Okay, so we'll go to main.py and we'll uncomment this code, so I can just do control / after those lines were selected, and that automatically got rid of the hash signs, but if you're in a text editor, just delete them manually. We'll save them and we'll run pytest again. Well, that didn't even get as far as last test. We've now got the year 2000 showing up as true when it should be false. Sorry, assert false. It should be false, but it's showing up as true. So let's uncomment again and run our pytest. And now we've run one test and that passed in 0.02 seconds. So that's all very good. So Leo's obviously done a lot of test work, so he's got lots of hints for us. Tests are collected and executed by pytest in alphabetical order, with the file test A, then test B, then test C, etc. Okay, so that's a good thing to know if you when you're naming your files and you want them to happen in a particular order, to do them in alphabetical order. And we'll have a look at the HTML reports later once we've done some more tests. Okay, so we're going to use parameters in our test function now. So in our test here, you can see we're having to do a separate line for each one of these, and we're repeating code. And if you've got some more complicated tests, then there could be quite a lot of repeated code if we had to do it this way. So what we can do is we can use parameters in the way we define our tests. So here's an example of a parameterized function. Not sure if that's really a word, but that's what they use. So we define our test here. Test is leap year with parameters, and we can put in some parameters here that will be passed in values, and they'll be passed in one row at a time. And we've specified here where they go. So the first one goes to year, the second one goes to result. So 2016 is true, 2019 is false, 2000 should be true, 1900 should be false. I'm going to put a print command in here to print what we're testing, and then I'm going to assert the results. and I'll put a carriage return at the end. Alright, so I'll leave the other test there, test is leap year, and we've got test is leap year with parameters. So we've got 2 tests in our file. Let's try running them now. Okay, now you can see what's happened here. It's now said we've run 5 tests. It's given us a dot for each one of the tests that we've run, and they all passed in 0.04 seconds. So this is an advantage of parameterize, is that it runs each group of parameters as a separate test. So we're getting that's counting as 4 tests, while up here only counted as 1 test. And that means, you know, if one of them was wrong in here, say I had 12, it's easier to make the test wrong than to actually make the function wrong. So in this case I'll do that, and I can see it went pass, pass, a failure on the 3rd test, and then pass and pass. So the 3rd test, the first test is this one, the 2nd test is this one, and the 3rd one is that one. That's the one that failed. I can read more information. The one that says year is 2012 with a result of false, that failed. It shows me exactly where the error is. It evaluates the different things. Is leap year 2012 evaluated to false? Our test said it should be true, so we had true is false, and that threw the error. So it caught that and told us exactly where our problem was. So I'll put that back. And run it again, all tests pass. So when you're designing your tests, it's pretty important to try to make your test independent of the code that it's testing, because if you've got a bug in your code, you don't want to repeat the bug in the test, because then the test and the code will agree with each other, and you'll end up not finding that bug, because it'll be in both the test and the code. So in this case, rather than just say looping through a whole bunch of years and checking in my test whether they were divisible by 4 or 100 or 400, and then seeing if I came up with the same answer as my is leap year function, I'm passing in actual data that I know covers a lot of the edge cases, and hopefully then the function will this is data I know is true, is correct, and my function then will test for those cases. That's, you know, often is really hard to do, is to write these tests in that way, but that's the trick. The other thing to make your testing work a lot better is when you write functions, is try to make them totally self-contained. So don't use global variables in here. If I had a global variable in here, I can't pass it in as a parameter, and so if the global variable affects the outcome, then it's going to make it hard for me to test. I have to set up global variables in my test function before I test the function to make sure that it returns. Alright, Leo's got more hints for us. PyCharm is test smart too, can try just clicking on the arrow by the test. That is true. So let's show how that works. I'll just exit my terminal down the bottom here, and there we go. Yeah, so I've got a play, so I can just run this test here. So PyCharm's already worked out that this is one of my test files, and so I can run that, and it says it's passed. That's good. One of the other things we didn't notice before is I had the print statement in there. Let's run this one, and let's run the 4 tests. and it's given us some information, testing, but it doesn't say what we're testing. So, oh yeah, there it is. There's the print statement. So PyCharm is actually showing us the results of print statements in our tests. Now, if I was to do this in the terminal and run pytest, then all of those print statements, and if I had logging statements in there, they're all swallowed up, and so you don't actually see them. So PyCharm is actually giving us a bit more information, which is can be good, can be useful. All right, and I could probably also select this whole file, test main, and I'll do a Control-Shift-F10 on that. Python test in test main, and so I just did Shift F10, Control-Shift F10 for my current file, and it just ran all the tests there, all 5 passed in 0.03 seconds. All right, let's try pytest-v according to Leo, and I'll do that in the terminal tab. So that's giving us some more information. It's not giving me my print statements, but it is giving me more information about each test that was run and which parameters were used during the run and whether they all passed or failed. Maybe we should put a failure in there just to see what that looks like. Test is leap year, that failed. Passed. Oh yeah, because I just changed that one. And let's try in our parameterized data. And that showed which one failed, and we get the error messages down below. So these are very useful. This automatic testing I really credit with the improvement in quality of software over the last 10 years. It's just really been, it's just got so much more reliable, and I think this is going to be one of the major reasons. All right, let's try Leo's report. So we're going to use -v for verbose. We're going to say using HTML create a report.html, and we're going to run test main.py. Alright, and let's have a look in our folder up here. And there's our report.html. So let's open this with a browser. What am I using? Chrome. So there's quite a nice HTML output. It shows where the errors were. Yeah, so that's all good. So are there any questions on this? Leo's got a lot to say tonight, which is fantastic. I'll just wait for what he's going to say. So, yeah, next week Aaron's going to be taking our machine learning class, so that will be very interesting. And the week after that's when we're going to get into Raspberry Pis, and I hope Leo's going to come along to that, because he can poke holes in my electrical circuitry and tell me what I've done wrong there, but also explain why it works, for how we can control our Raspberry Pi using Python on both the Raspberry Pi and our PC, and communicating between them using a messaging queue. We're going to be using MQTT. All right, Leo said the failures are always at the start, so it's always good to know. I found other things you can do is you can group your tests, so that sometimes I've got some tests which are quite slow, so I don't want to run them all the time, but I just want to run the quick tests. So by grouping them, that makes them, I can quickly just run the quick tests, and then at longer intervals I can do the slow tests as well. Okay. So that's all for tonight. Thanks for all your attendance, and I hope you enjoyed it, and thank you very much to Leo for all his suggestions as well. Talk to you soon.